Hello students, welcome to today's chemistry class. The learning objective is about the amines. What are amines? There are different functional groups. In that functional groups, you have hydroxy compounds, we have carbonyl compounds, we have acids, we have esters, we have ethers. All these are different functional groups. So today's a chapter which we are going to study is about the amines. Derivatives of ammonia. Amines may be regarded as the derivatives of ammonia, in which one or more hydrogens have to be replaced by alkyl groups. So NH3 ammonia, one hydrogen is replaced, it will give you methylamine, alkylamine. It's a primary amine. And if in the ammonia, another hydrogen is replaced by R group, you get dialkyl group. That is secondary amine. And in ammonia, if the three hydrogens are replaced by, if three hydrogens are replaced by alkyl groups, you get tertiary amines. So amine is the derivative of ammonia, where one or more hydrogen atoms have been replaced by the alkyl groups. And if here you have an aromatic group, then that is aromatic amine. If you have an alkyl group, that is aliphatic amines. Now let us have look on to the structure IUPAC nomenclature. In the IUPAC system, amines are regarded as alkanamines. Example, this is one carbon and here this is second carbon. So ethanamine. And here this NH group it is having one is ethyl group and the other one is the methyl group. So methyl ethyl amine, alkanamines. And the nitrogen, the three bonds are replaced by the alkyl groups, ethyl group, ethyl group, ethyl. So N, N, di-ethyl ethanamine. Now we'll go for the structure. The nitrogen atom in amine it is sp3 hybridized. The nitrogen atom in the amine it is sp3 hybridized. It is having pyramidal structure, one lone pair of electrons and three methyl groups. The three hybrid orbitals are involved in bond formation and one hybrid atomic orbital contains the lone pair of electrons, giving the pyramidal geometry for amines. In aryl amines, NH2 group is directly attached to the benzene ring. In the alkyl amines, it is attached to the alkyl group. And you have a primary, secondary, tertiary hub. If the NH2 group is attached to one R group, then that is primary amine. If the NH group is attached to the two R groups, then that is the secondary amine. If N is attached to three R's, then that is tertiary amine. And if the NH2 is attached to the aromatic group, then that is the aromatic amine. Now we'll see the structure. As I've explained you, it is the pyramidal structure. The nitrogen it is having pyramidal shape with one lone pair of electrons and three methyl groups. In aryl amines, bond NH2 group is directly attached to the benzene ring. Here, the benzene group, it is attached to the NH2. It is benzamine. Next, if the phenyl group is attached to the two methyl groups and one aryl group, then that is a N-ion dimethyl benzamine. We'll see the preparation of the amines. Reduction of the nitro compounds is one of the preparative method for the amines. R bond NO2 on reduction, it gives RNH2 amine. So nitro group is reduced to NH2. Oxygen is eliminated and the hydrogen is added. So removal of oxygen and addition of the hydrogen is reduction group. Reduction can take place by tin and HCl. Also nickel and hydrogen. Next, zinc and sodium hydroxide also function for the reduction process. And palladium catalyst and hydrogen also can reduce the nitro compounds to amines. Now, the reduction, we'll see the reduction of the nitroalkanes or nitrobenzene in the neutral medium gives hydroxylamine. Ammonalysis of the alkyl halides. NH3 on reaction with alkyl halide gives substituted ammonium salt. Similarly, the substituted salt on reaction with the sodium hydroxide, RNH2 primary amine is formed. Along with the byproduct sodium halide and water. In a similar way, ammonalysis is the reaction of ammonia with alkyl halide. It gives primary amine, secondary amine, secondary amine, tertiary amine can be formed by the ammonalysis of the alkyl halides. Here, RNH2 on reaction with RX gives rise to R2NH. This is the secondary. Because two R groups are present, it is the secondary. If one R group is present, it is primary. Two R groups, it is secondary. RX, again this R2NH on reaction with RX gives rise to R3N. This is tertiary amine. And further alkyl halide can still be added to this tertiary amine, which gives the quaternary ammonium salt. Ammonalysis has a disadvantage of yielding mixture of all the four amines: primary, secondary, tertiary, and quaternary ammonium salts. However, primary amine is obtained as a major product by taking large excess of NH3. Order of the reactivity of halides with amines is Ri, it is greater than Rbr, it's greater than RCl. Now, aromatic amines couldn't be prepared since the aryl halides are much less reactive towards the nucleophilic substitutions. So, aromatic amines cannot be prepared using the aryl halides due to the less reactivity towards the nucleophilic substitution. Alkyl halides, so you cannot prepare aromatic amines using the aryl halides. Now, The aromatic amines, how later we can see the preparation. We'll see the reduction of the nitriles or cyanides. Here R C triple bond N is cyanide. It is cyanide. This one on reduction in presence of nickel catalyst and hydrogen in presence of sodium mercury or ethanol, the alkyl amine is formed. And the fourth preparation is a SMID reaction. RCOOH on reaction with hydrozoic acid N3H will give us the concentrated H2SO4. RNH2 alkyl amine is formed with nitrogen and carbon dioxide. This is the modified Curtius degradation reaction. Now, reduction of amides. Reduction of amides. Amide is nothing but RCONH2 is called as the amide. RCONH2 is known as amide. CONH2 group is amide group. NH2 is amine group. Amides on reduction, removal of this oxygen and addition of hydrogen. So amides on reduction, that is with lithium aluminum hydride and water, we get amines. Now, Gabriel phthalimide reaction we'll see. This is phthalimide. Phthalimide on reaction with alcoholic KOH gives rise potassium phthalimide. Gives a potassium phthalimide. Now, this one on reaction with alkyl halide, we get N-alkyl potassium phthalimide. N-potassium phthalimide on reaction with KOH, we get potassium phthalate. Okay, the bond is getting cleaved over here for this one and for this one. And potassium, OK is added. So potassium phthalate is formed with RNH2, primary amine formation. Now, it only produces primary amines. This method is suitable for primary aryl amine because aryl halide does not give nucleophilic substitution reactions. So, and Hoffman bromamide degradation reaction is the next preparation. See, ammonolysis can also be called as the Hoffman method. Yeah, this ammonolysis of alkyl halide can be called as the Hoffman method. And the IUPAC nomenclature here, amines the IUPAC nomenclature. The common system is methylamine. If two carbons are there with NH2, it is ethylamine. If ethyl group is there for NH2, it is ethylamine. If methyl group is there for NH2, it is methylamine. If two methyl differently are present to the nitrogen, different bondedly, then that is dimethylamine. If one methyl group and one ethyl group is present, then that is methylethylamine. If three methyl groups are present, then that is trimethylamine. If if an isopropyl group is present for the amine, then that is isopropylamine. This is the common system. And for the IUPAC system, primary amines can be named as amino derivatives of corresponding alkenes. Secondary and tertiary amines are regarded as N-alkyl substituted derivatives of amines. Methylamine, methanamine. Methylamine can be called as methanamine. Ethanamine can be ethylamine can be called as ethanamine, and dimethylamine, the common name, can be called in the IUPAC system as dimethylmethanamine. And similarly, methylethylamine can be called in the IUPAC nomenclature as N-methyl, N-ethylethanamine. So N should be used. So N-methyl methylamine, N-methylethanamine, N comma N dimethylmethanamine. Similarly, N-methyl comma N-ethylethanamine. So that N should be, we have to use the N alkyl substituted derivatives of amines. So capital N alkyl substituted derivatives, they should be called in that way. So N methyl N ethanamine. Now the 1-propanamine, similarly 2-methyl 1-propanamine. This way we can call. And coming to the aromatic amines, we have aniline. If benzene ring is having an H2, we call it as aniline. If benzene ring is having an H2 and CH3, we can call it as orthotoluidine. If benzene ring is having methyl group and NH2 group, then it is metatoluidine. And if methyl group and NH2 group are present at the para positions, then it is paratoluidine. Now we'll see the classification also I've told you as the primary amine, secondary, tertiary. If one hydrogen atom in the ammonia is replaced by one alkyl group, then the primary amine, if two hydrogens in the ammonia is replaced by two alkyl groups, then the secondary amine is formed. If three hydrogens are replaced by three alkyl groups, then tertiary amine is formed. And the ammonium salt is tetrahedral symmetrical ion. If it is possible one or more hydrogen atoms of ammonium by alkyl groups, all the four hydrogens of ammonium ion are replaced by alkyl groups. So we get tetraalkyl ammonium or quaternary ammonium salt, or we get the quaternary ammonium salt. Now we'll see the preparation of the amines. Preparation of amines already have explained you. Coming to the preparations, first preparation, it is from the reduction of the nitro compounds. Palladium hydrogen tin chloride or nickel hydrogen and zinc NOH, all these can be used for the reduction process. So the reduction of the nitro compounds can form amines. Similarly, ammonalysis of the alkyl halides. Ammonalysis of the alkyl halides, the NH3 on reaction with the RX, NH3 on reaction with the RX, it gives substituted ammonium salt. So whatever it may be, the primary amine, secondary amine, tertiary amine, and quaternary ammonium salts can be formed using the alkyl halides. So this ammonalysis of the alkyl halides is called as Hoffman method. This is called as the Hoffman method. Now we'll see the next preparation, reduction of the nitriles and cyanides. So reduction of the nitrile or the cyanide in presence of nickel hydrogen, sodium mercury ethanol, or CH2NH2 is formed. So primary amine is formed. Similarly, Schmidt reaction, very important reaction. Acids on reaction with the hydrozoic acid. Acids on reaction with the hydrozoic acid gives CO in presence of concentrated sulfuric acid, gives alkyl amine, and nitrogen and carbon dioxide is formed. This is a modified Curtius degradation reaction. It is a modified Curtius degradation reaction. This is the fourth preparation of the amines. Now, the next one is reduction of amines. In the reduction of amines, RCONH2, the amide group on reduction with the lithium aluminum hydride in water, it forms RCH2NH2. Now, the next preparation is Gabriel phthalimide reduction. Gabriel phthalimide synthesis. In this reaction, phthalimide is treated with KOH to form potassium phthalimide. This reacts with alkyl halide to give alkyl phthalimide. Hydrolysis of this alkyl phthalimide with HCl gives primary amine. With primary amine. So phthalimide on reaction with KOH gives potassium phthalimide. This one on reaction with alkyl halide it gives N-alkyl phthalimide. And this one on hydrolysis it gives phthalic acid and primary amine. Okay. It produces primary amines and this method is suitable only for primary aryl amine because aryl halide do not give the nucleophilic substitution reaction. Now, the next preparation, it is Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. Amide on reaction with bromine in presence of sodium hydroxide gives amine. So this CO group is eliminated. Therefore, RNH2 group is formed. RNH2 is formed. CO group is eliminated. Therefore, RNH2 is formed in presence of bromine and sodium hydroxide. So, our amide gives amine is Hoffman bromamide degradation reaction. One CO group is degraded. Sodium carbonate, sodium bromide, and water is formed. And looking onto the mechanism, when the amide aliphatic or aromatic is treated with bromine and potassium hydroxide or sodium hydroxide, primary amine is formed. The mechanism involves different steps. You have almost 5 steps of the mechanism. In Hoffman degradation reaction, amine has one carbon less than parent amide. This amide is having your one carbon will get lesser. So carbon is getting lesser. So it is degradation method. That is the reason we call it as the degradation method. In Hoffman degradation reaction, amine formed has one carbon less than the parent amide. To obtain primary amine, in order to obtain primary amine with same number of carbon atoms from primary amide, reduction is done with lithium aluminum hydride in presence of ether. It is done in presence of ether. So physical properties of the amines. The lower aliphatic amines are gases with fishy smell. The lower aliphatic amines are gases with fishy smell. Primary amines with 3 or more carbon atoms are liquids and the higher members are all solids. Higher members are all called as the solids. Lower aliphatic amines are water soluble because they can form hydrogen bonds with water molecules. However, the solubility decreases with increase in hydrophobic alkyl group. Hydrophobic alkyl group. Boiling point order of the primary, secondary, tertiary is as follows. So boiling point of the primary amine is more than the secondary and the tertiary. See, the tertiary is having 3 aryl groups and steric hindrance and easily that gets breaked up. So the boiling point is less. And then for secondary and then comes for the primary. Tertiary amines does not have intermolecular association due to absence of hydrogen. Tertiary amines does not have intermolecular association due to absence of hydrogen atom available for the hydrogen bond formation. Now, basic strength of the amines. Let us look onto the basic strength of the amines. Basic strength, if you see, amines act as a Lewis basis due to presence of lone pair of electrons on nitrogen atom. More is the dissociation constant of Kb, higher is the basicity of amines. Lesser the pKb, higher is the basicity of amines. Aliphatic amines are strong bases than NH3 due to electron releasing effect of the alkyl group. Among aliphatic methylamines, the order of basic strength in aqueous solution is as follows. So first is for the primary amine, that is ethyl, then for the tertiary. This is the formula. And similarly for this secondary, primary, and last is tertiary. Then ammonia, the basic strength. Due to steric hindrance, more are the methyl groups, alkyl groups, more is the basicity. Because these are the plus I groups which donate electrons, thereby the basicity is increased. Thereby the basicity is increased. Okay. Aromatic amines are weak bases than the aliphatic amines. I think you have understood the basic strength of the amines. The methylamine, as the methyl groups are increasing, basicity increases. Methyl groups are the electron donating groups plus I groups. As the electron is donated, the nitrogen will have more electrons and it is having more basic nature. More basic nature. So the secondary amine, it is having more basic nature than primary. Actually, tertiary should have more basic nature, but due to steric hindrance, it is getting decreased. So as the alkyl groups are increasing, the basicity is also increasing. Aromatic amines are weak bases than the aliphatic amines and NH3. This is the fact due to that the electron pair on the nitrogen atom is involved in resonance with pi electron pairs of the ring. So electron releasing groups, that is methyl group, methoxy, bond NH2 groups, increase the basicity of the aromatic amines, while electron withdrawing groups tend to decrease the same. Now, orthosubstituted amines are usually weaker bases than the aniline, irrespective of the nature of the substituent, whether it is the electron releasing or electron withdrawing. This is the ortho effect, and due to steric and the electronic effect, it happens. So these are the physical properties of the amines. So today's class, what we have discussed is about the primary amine. What are the amines? Nomenclature of the amines, structure, preparations of the amines, different ways, and physical properties of the amines were discussed in today's class. So next class, I'm going to discuss about the chemical properties of the amines. Thank you everybody for listening to my chemistry class.